So, here's a graph. Can you tell what function that is?
Equals x squared.
Huh?
X squared.
X squared?
Y equals x squared.
1 over x squared maybe. X squared looks like this, right?
That's true.
Okay? So that'd be possible. Yeah, the two basic functions, and you should recognize this, and if you don't, you should practice graphing these things. You should graph, you should go through the whole set once a day for a week and make a table and graph every one. So you can do this because we're going to use these. And if you're not quick at doing it, then you're probably not quick at visualizing it or thinking about what it's telling you, okay? So you really need to be quick at doing this, as I told you a couple of weeks ago. Okay, so it could be a 1 over x, could be a 1 over x squared. Those are the two that look like this in the first quadrant, right? And if we're trying to match this up with a pendulum, well, we can see how this matches, right? So let's say you have this, and you want to know if this is a good pendulum graph. Now, by pendulum graph, I mean count, 1 minute count versus length, right? So, count per minute versus length. Okay, well, let's say at length 1, is 130 counts per minute at length 1. Okay? Well, now I can label this graph. Okay? I can put 130 on the y-axis and 1 on the x-axis, right? Of course, I can't put them just anywhere. I've got to put them so that, you know, the point 130, lies on the graph, right? So I'm restricted in what I can do. Now, I'm not restricted in what I can do when I locate the 1. If I want to put the 1 there, I can do it, right? And then the 130 has to go like there. Okay? Now I'm going to choose to put the 130 up here. So if I put 130 here, can you tell me where 1 should go? Well, I want you to raise your hand visibly, at least make some motion with your hand, preferably not a threatened one because I don't want to have to cower and run away. Okay? When I get to the point on the horizontal axis, it should correspond to 130, right? That should correspond to 1. In other words, if I have 130 counts when the length is 1, I want to know where 1 has to go on this axis. Okay? That makes sense? So, raise your hand when you think I'm there. Okay, most of you got your hands up. Okay, that's pretty good. Now, whether that was a mob phenomenon or not, you know, where everybody just does what somebody else does, right? And I don't think it was, because I think you're pretty good with it. But you see that if I go over here and down here, that's where 1's going to have to be, isn't it? That's about where I was when his hand started going up, okay? Maybe a little delay because people were looking around to see if anybody else's hand was up. I don't think I think you voted accurately and honestly. Well, in one way or another. You understand what I'm saying here, right? So once I figure out where 130 is here, I know where 1 has to go here if I know that there are 130 counts at length 1, right? Okay? Okay. So how many counts, according to this, would there be at length 3? Okay, well, where do you think length 3 is going to be? Tell me where to stop. Okay, around here? Yeah, that's pretty good. There's 1, there's 2, there's 3. That's just about where you said. Okay? Now, write down the number you think corresponds to the count per minute, if this is the graph. I mean, just a ballpark number. Think it's 200? I hope not. Okay. I'd have to reach way too high. You think it's negative 14? Clearly not. What do you think it is? Okay, now, how many wrote a number less than 50? How many wrote a number between 50 and 100? How many wrote a number bigger than 100? Okay, hope not. Okay, so that's pretty good. Okay, if I go up here and over here, I find that this ought to be the count, right? Now let's see. How many of those does it take to make this? 1, 2, takes more than 3 of these to make this, right? Okay? So this has to be less than a third of 130. A third of 130, a third of 120 is 40, right? It's less than that, so I'm going to say maybe that's around, 35. Now, do you think a pendulum of length 3 would have a count of 35? Well, you can go to your own data, okay? You counted it. You counted the pendulum for length 1. You counted the pendulum for length 3, right? Okay? So you got 2 counts. And you can draw your own graph using either the count for length 1 or the count for length 3 to label a point on this graph, okay? And then you can scale the rest of the graph and see if that predicts the right count for the other length, okay? Now, I don't think if you counted 130, your count was 35. I think that would make this an inaccurate curve, okay? And what's wrong with the curve? Well, 35 is way too low. You're not going to go from 130 to 35 by increasing the length from 1 to 3, okay? It just isn't going to happen. If you do the count, you'll find that that doesn't work. Okay, that at length 3, the count is higher than that. At length 3, the count is probably like 70. Okay? And if this is the, what you get from the 1 over x graph, or the 1 over x squared graph, that means the graph has gone down too steep. Okay, and there's no way around it. If you relabel it a different way, it's still going to mess up if you've got the graph of one of those power functions, okay? So you got to find the right power function. Now remember what a power function is, right? It's x to the p for power p. And there's a question on there, you know, what would 1 over x squared, is that a power function? And I think people did pretty well with that. I didn't see a whole lot of people that didn't get that. Unless the formatting screwed up, but then, then I think most people fixed it. Redid it when they got the formatting of the document right. Okay, so anyhow, so we want to find maybe what power P applies here. Okay? Now, your adjusted power function for the pendulum would be a y equals ax to the p, where a is some number you have to determine. Okay? So one thing I had you do was I said, okay, suppose p equals -1 and let's say length 3 gives you a count of 90. Okay? What can you do with this?
Plug them into the equation.
Yeah, well, and people did well with plugging numbers in. If they, yeah, some people made, with that backward apostrophe thing got confused, but I don't think you're going to have any trouble with it because a lot of people did this quite well. Okay? If you didn't, just kind of redo that one. Let's make sure. Because if you're not doing it, you're going to need the feedback. Okay, so if length 3 yields count 90, then I say it like this: x equals 3 when y equals 90. Okay? So first of all, if p equals -1, y equals ax to the -1, which means that y equals a over x. Everybody okay with that? X to -1 is 1 over x. So a times x to -1 is a times 1 over x, which is just a over x. So since p equals -1, y is going to be an ax to the -1, or y equals a over x. And not y is 90 when x is 3, so 90 equals a over 3. Okay? And we solve that easily. Multiply both sides by 3, you get h equals 270. Okay? That look okay? Everybody all right with that? Okay, then our model. So our model is y equals 270 over x, right? Okay? Since a y equals a over x, y equals a over x, we easily evaluate a from just one count for a known length, and we get our value of a. Now, it doesn't mean this is a good model. Okay, this is not going to be a good model for the pendulum. Okay, if x equals 1, then y equals 270 over 1 equals 270. Okay, well, depending on how you counted, you might have gotten 90 for your pendulum of length 3, but nobody got anything close to 270, did they? So whatever your count is, it's not going to match this model, okay? So we're going to say that P equals -1 model is not good. So I've got different numbers up here. But for the same, in the same way, this model doesn't work well. This model doesn't work well. Okay? So we haven't found a good curve. We haven't found a good model, unless this fits your data reasonably well. Okay? So what I'm going to ask you to do for homework is I'm going to say take your own numbers and do what I just did. Okay? Plug in your count 3, find your value of A, and then compare that with what you get when your length is 1. And see if it comes close to matching. Okay? That makes sense? Not difficult. Because people are doing pretty well with the idea of substituting your numbers and solving for like A. At least with substituting the numbers. Okay? Y'all did pretty well with that as a group. If you didn't, give it another shot. Get my feedback. Send me an email saying, hey, when I do this, I do this. If you want me to check it. Okay, we could try another model. Okay, so and I'll tell you, there is a value of P that works very well for this pendulum. Okay? We want to try to find the value of P that works best. Now, different people got different paths and there are different little uncertainties. Not everybody's going to get the same value of P. But when we finally do this, people are going to get values of P that don't differ by a whole lot, unless you've really screwed up your count. Okay, so what we do here is we say, okay, well, let's see. We actually have 2 data points, don't we? Okay? So we know, let's say we know that y equals 130 when x is 1, and y equals, let's say, 90 when x equals 3. There is a power function that will exactly fit these 2 points. And we can find it, except there's one step that most of us won't know for about a month. And we'll fill in that step later, but the process is the same whatever model you're trying to make. The process is just this. Okay, so assume y equals ax to the p. Now, x and y are, the count and the length, right? Well, the length and the count in the order I said it. So those are variables. But a and p are going to be fixed numbers. Just like here, we found out what a was. It was 270, so that's what a was going to be, right? Okay? And we had power, I specified a power of -1 here, but now I'm not going to specify the power. We're going to have to figure that out. So there are 2 things we got to find. We got to find A and we got to find P. We can't do that with just one equation. You have to have 2 equations. Okay? Very important. Ideal. So we can get 2 equations because we got 2 data points, right? So y equals 130 when x equals 1 tells us that 130 should equal a times 1 to the p. And that 90 should equal a times 3 raised to the p. Okay? Now, can you tell me what a has to be? Actually, first equation tells you. Can you solve that first equation for A?
130.
Huh? It's 130. Because coincidentally, and this doesn't always happen, but x equals 1, so any number, 1 to any number is 1, right? Any power of 1 is equal to 1. So we just kind of luck out here, but we immediately find that A is 130, right? So this implies that A is 130. So 90 equals 130 times 3 to the p. Okay? Now, in order to solve this equation, since that p is in the exponent, turns out you have to use logarithms. How many of you are comfortable with logarithms? Good. But there's no reason to expect any that you are, because it's not part of your prerequisites. Okay? If you haven't done logarithms, then you're clueless as to how to solve this, so we're going to have to learn to do that. But we're not going to bother with that for about another month. Okay, there's a lot of other things we need to do to even get to the point where we can have a good understanding of what logarithms are. Okay? So we got to do that. Now all you're going to do, I'm going to give you some problems that ask you to do this. I'm just going to say, okay, try it for power -1. Doesn't work. Try it for power -2. Probably going to find it's even worse. Okay? So you're going to prove that neither of those powers works. Now, if -1 is bad and -2 is worse, what's that tell you about the power? What would happen if I went to -3? Well, you're not sure, but you would kind of expect if going from -1 to -2 made it worse, -3 would make it worser. Or worser, or I don't know which one. Okay? So maybe your power ought to go up a little bit, right? And if you understand power function, you understand the power can't go over 0, because then the function starts going up. And the pendulum doesn't do that. The count doesn't go up when the length goes up. Okay? So you may be going to end up with a power between 0 and -1. Okay? And then you got to learn to deal with those powers. So we're not going to worry about that until we refresh a little bit of algebra where you can actually do that. Okay? And you really kind of have to use a calculator at that point. I want to avoid that for the moment. Okay, get the idea, though? That what we're trying to do is we're trying to figure out the graph that matches the behavior of the pendulum. Okay? And we're doing that by substituting data into the form of a function that we think might work. Okay? Physics predicts what function should work. And the function we actually get for a real-world pendulum doesn't quite match the physics, because the physics assumes that there's no air resistance and stuff like that. Okay? But it comes out close to what physics predicts. Okay.